When I think about the challenges and opportunities of electric cars that lie ahead of us, there are many questions that I ask myself. For example, when many electric cars charge at the same time at the same location, will they overload the electricity grid? Can we give old car batteries a second life as storage? And could it be possible to share the energy of electric cars, which are anyways parked over 90% of the time, with our neighborhood? And maybe even earn money with it? With these questions in mind, I visited the Mobility House, a company which has the vision to create an emission-free energy and mobility future. The following interview will cover how their solution solves the network load problem when charging many cars, how they use new and old car batteries at an arena in Amsterdam to reduce emissions and save money, how electric cars could help stabilize the electricity grid and how this might help in our quest towards more renewable energy, and how they pilot their technology on the island Porto Santo. If you want to directly jump to one of these sections, there are time markers in the video description. So let's get started. Hello everyone, welcome back. Today I'm here at the Mobility House in Munich and I'm meeting Markus Fendt, a managing director of the Mobility House, and I'm really glad we can have this conversation today. And yeah, maybe you start by talking about what Mobility House is about and what the vision is behind Mobility House.
Thanks, Paul, for having me. The pleasure is mine. Mobility House was founded by a good friend and my former boss, Thomas. And he had the vision that by buying a Tesla Roadster in 2008, this huge battery is absolutely unutilized because it's a sports and a fun car. It's sitting in the garage the whole week. And he said, well, what can I do with that battery? Right. And living in the Alps, knowing about pumped hydro and storage, and foreseeing that more and more renewable energy is needed in the future to tackle climate change, he said, well, this is the solution. We have renewable energy, which is very volatile, and we have electric vehicles, which are a lot of fun to drive, right. Which have a huge storage capacity you hardly use, you do not utilize because your normal car is sitting 23 hours a day in a garage somewhere. Just driven for an hour for 40 kilometers. So if you bring that together, you solve a couple of problems. First, the volatility of the renewable energy, of the intermittence of that energy production. Second, you can store the energy at least for a couple of hours or days. So it's not a long-term storage, but for a couple of hours. So being from day to night or from a windy night to a not sunny day. And to bring that together, save CO2, enable renewable energy, and at the end earn money with that battery because storage is valuable. You get paid for storage. Pumped hydros are paid very well, though the Austrians and Swiss earn some money with their pumped hydro. So you can make electric vehicles much cheaper than we actually all think. That is the vision, and with that vision we started in 2009 and founded the company. I joined half a year later, and since then we try to realize that vision step by step.
What is your personal motivation in working in this field?
When Thomas explained me his idea, I said, wow, this is a disruption. And to work in a disruptive industry, I think is the most exciting thing you can do. Because nothing stays as it was before. Mm-hmm. And 10 years ago, it was not so obvious for most of us. Now we are 10 years further. What you currently see in the automotive industry is a huge disruption. What you see in the discussion about climate change, this was for freaks or scientists, a topic 10 years ago. Now kids go leave school and go on the street to demonstrate about doing those things we have already known 10 years ago. So this disruption is just exciting. It's tough, it's a lot of work, but at the end it's something which motivates a lot that we work on a technology basis to a better future.
So, what about charging many EVs? If you live in a single family house, you can install a charger at home without worrying that your grid connection overloads. But what if you live in an apartment building, or you want to equip your hotel or company parking space with many chargers?
We certainly have an issue in multi-dwellings, condominiums, where we need controlled charging, because there you have a limited grid connection. If all people come between 5 and 7, you might have a grid connection issue.
This was my next question. Like, is there a network load problem with the electricity grid if all people try to charge at the same time?
Yeah, this is what you have to solve. Otherwise, it's the same. Installation in a garage, you have all these cable conduits normally in a garage, and future buildings are required by law anyhow to be equipped completely or to be prepared for e-mobility charging completely by EU law in the future. So it's not, sometimes it's a matter of costs, but the really relevant issue is always the grid connection.
So I know that you're working on a solution, or you already created a solution that is called the ChargePilot, which is trying to monitor and balance charging. How does it work and what is it about?
That's the first step of our vision, where we always say control, monetize the battery. The first one is not earning money with the battery to the energy market as described in our vision in the beginning, but it's saving money by charging at the right time. So without burdening the grid and with charging when the energy is cheap. For example, in California, you get half the price if you charge after 11 o'clock at night. So considering that, we developed a charging and energy management system. We have it here. It's, at the end, it's a software which controls the charging of the different vehicles in a condominium, in a corporate parking place, in a parking house, wherever you have several chargers to charge, vehicles to charge, that by several algorithms you consider the maximum power of the vehicle, but also of the grid. When does the vehicle need to leave? You can prioritize it. So all the things that you optimize the charging by realizing the mobility needs of the driver are incorporated in a software, and this software we have on that. It's an industrial Raspberry Pi. You integrate in your switchboard. It's all based on open interfaces so that you can connect all the different charging stations you would like to have. One would like to have a green one, the next one a blue one with 11 kilowatt, the next one with 22 kilowatt, one with RFID, the next one without. Some DC charging, so this is all incorporated here.
So now here we can see the ChargePilot dashboard in action. What can we see at this moment here?
So what you see here is a customer with a garage with 9 charging points. 2 cars are currently charging. This would be the dark blue area. And the grid connection is limited with 70 kilowatt. And the light blue is the building curve. And you see the building curve is fluctuating. These are loads which are switched on and off. The small hills are always the elevator. So the elevator is around 10 to 20 kilowatt you use for that elevator. And the funny thing is, I show it to you, actually it's coming right now. What you see here is, so this is the time frame of a minute. You see here the elevator fully loaded because it's more than normally these 20 kilowatts, it's 30 kilowatt. Right. And we are hitting the grid load if we would also charge the vehicles. So what you see here within seconds, our charging and energy management system, the ChargePilot, reduces the charging of the vehicle immediately to not hit the grid load. What is the advantage? The customer they do not need to invest in a bigger cable. So they save on grid extension. And also they save on demand charges because you have to pay that thicker cable the whole year, the bigger grid connection. And this small example would be the same as we discussed before in a condominium. So everybody would start cooking at night. So you can charge your vehicles at that time because the grid connection is limited. So you just deferred not here by a couple of seconds or half a minute. You would then defer it by an hour or 2 hours.
So yeah, I mean, that's a really easy to understand example. So okay, the elevator is using a lot of electricity, and then you just reduce the charging of the cars, and then later on you increase the charging again when the elevator finished going up and down.
Exactly.
So in which cases exactly can an energy management system be useful?
Every customer who wants to install more than, I would say, 5 charging stations and then grow over time, or has different charging stations and has a limited grid connection, should use a charging and energy management system as we offer it. We call it ChargePilot, because with that you have the possibility first to reduce and to optimize your grid load and to avoid high demand charges. So just to give you an impression, a normal customer with 10 charging stations and a profile, assuming these are logistic cars, for example, coming to your garage at night, would create a peak. Because they are more or less coming at the same time. That peak you pay around 10,000 euros a year. This we can totally avoid because we flatten that peak over the whole night. And then therefore you should consider in the beginning a charging and energy management system if you are a customer like this. If you are below 5 charging stations, you also might work with local master-slave system charging station manufacturers offer. If you do not want to extend later, you can also use that. And then key is to have one with open interfaces. We do not have a vendor lock-in. So that it works with different charging stations, because you do not know if you will use the same charging station in 3 years from now than you use today. And also there are continuously protocol upgrades. For example, the next big thing will be plug and charge. So you don't need the RFID cards anymore to identify yourself. This will be done by the vehicle. So you just take the plug, you plug it in, the vehicle communicates with the charging station, and then you are identified and authorized, and also the billing will be done via that new communication standard, which is in the finalization process now. And have open interface to the energy market, which is our key, because we will see more dynamic tariffs as well from the grid side, as well from the energy side in the future. So then you save a lot of energy cost if you charge when the sun is shining right now. We had a couple of clouds already here causing some light issues during our movie. This would exactly the time where you would slow down charging perhaps, because you do not have the cheap energy available on your rooftop PV anymore. And therefore you want to have that control possibility. Therefore you should use a charging and energy management system with a lot of interfaces to the energy world.
How would you regulate the charging depending on, for example, the shining sun? How would you slow it down? Where do you get the data from for something like that?
There are 2 ways. Either it's your own PV solar system, then that's normally connected to an energy management system or some kind of monitoring system, and we would get information via an interface, normally a Modbus interface, which we can incorporate. So we wait until 9 o'clock when the sun is shining, then we start charging the cars.
So you schedule the time then in this case?
Yeah, normally there is a prognosis behind in this information system. You know, okay, this will be a sunny day, and the sun will appear by, let's say, 8:39 or whatever, and then you would defer charging of those vehicles which do not need to be charged immediately. Consider workplace charging, like here our employees come, we wait, some might come at 7, not all the IT guys, but some come at 9, so we would start charging as soon as the sun is there. And we could stop charging when there is a cloud, like today, and then we start 50 minutes later again when the cloud is gone. But you also have these overall signals, not in Europe so much, UK a little bit, but especially in the US, it's so-called demand response signal. So somebody will give you a signal and say, please increase load or reduce load, and pay you according to that signal. This signal we can incorporate. There's the protocol, for example, OpenADR, which is also an open standard. We have incorporated in our charging and energy management system already, where we get that signal and then would reduce the load of the vehicle. However, always considering the mobility needs of the driver. So you, Paul, you would like to leave in an hour, so we wouldn't reduce you because your car needs to be fully charged. Elena needs to leave at 5, so we could easily reduce her charging power because she has the whole afternoon to be charged.
I think this sounds like a really great solution, incorporating the customer needs, but also looking at the weather conditions and being able to integrate aspects, how much renewable energy is available in this moment.
Only if we do that, we at the end achieve CO2 savings, we achieve the high utilization of renewable energy, and by thus also contributing to our climate goals.
So what data can you collect with the system? What's the most important data that you have when you use ChargePilot?
There are operational data, for example, charging power, mainly on which phase you have that charging power, because we can also balance the different phases. We have in Germany 3 phases. In the Netherlands or in the UK it's just 1 phase. There it's not so relevant. But you don't want to have an imbalance in the phase. So we collect that data and then distribute the charging between the different phases. We certainly have the building load. We can get data from connected interfaces like an energy management system of the building. And we also have the data when given by the driver when they need to leave. For example, we are controlling close to 10% of the European e-bus fleet. And e-buses, they all have a schedule. Right. So that schedule data we get, we incorporate and we charge according to the schedule. So there are buses which have longer routes. We certainly charge more than buses with shorter routes. Or also the parking position. If your bus is in the front, you have block parking, and you certainly want to charge the first bus first, because that bus has to leave first and then needs a full battery.
So the billing can also be separated between different users.
Exactly.
And how about predictions? So you collect a lot of data. Do you already have the ability to predict certain charging patterns and know in advance which days of the week when there will be the most cars charging at the same time? And can you kind of incorporate that into some tactics to let people know?
So you understood the vision from the beginning of our talk. Certainly this is what at the end creates additional value. So that you understand pattern, you even get the information from the driver and then say, okay, I can offer a certain load to a customer, to the market. I can also offer energy to the market, so when there is energy needed in the future. So what we incorporated already is that we gather that data, we do first trials where we understand and see how can we aggregate this data, how can we manage this data between the different charging and energy management ChargePilot systems in a building, in a street. We work with grid operators there, for example, to provide them that data so that they know, okay, we will have a grid issue in that road at that time.
Okay, so you work together actually with grid operators to...
We need to. So
definitely. So it's actually obvious, but I didn't think about it.
I think this is also something of the new world. It's not most of the things in disrupting the existing energies you can't do for your own anymore. So there will not so many Apples and Googles of this world be in the future, but it's much more on a collaborative, cooperative basis. That you work together with a grid operator, with the energy markets, with the customer, and to bring all the bits and pieces together. And therefore, you need data from the driver, from the grid side. You have to provide data that somebody else can optimize, and by that we achieve an optimum.
You have some very interesting battery storage projects at the mobility house, where you also try to use old car batteries and reuse them as a storage system. What is the idea all about with the storage locations?
Yeah, it's a funny story because, as I said, we had the vision to incorporate the vehicle into the energy world. By that, the vehicle has to be bidirectional, so not only charging at the right time, but also discharging, because by that you create the most value. So you have a storage, the pumped hydro I mentioned in the beginning. So we backed each car manufacturer. Don't you have a bidirectional vehicle? And Nissan was the only one who had it from 2012 onwards, I think, if I remember right, 2012, 13. Daimler, for example, we discussed heavily with them, can't you do something? And we did a pilot and some calculations. And then they said, you know what? I don't have a vehicle, but I have batteries. So why don't you take the vehicle without wheels? And then we said, wow, actually a good idea. We can try a lot of things already. We can develop our software stack already, incorporating a lot of things needed for the energy market without bothering about the customer. So what we did is we got close to 1,000 batteries from Daimler, installed them in a hall, kind of in heavy-duty shelves, together with Accumotive, which is the Daimler energy daughter now. We built a battery management system, and we aggregate these batteries to the energy market and learned how to charge and discharge them at the right time to generate money, monetize those batteries, but also to consider the aging of the batteries. And over the course of, we did the first storage 2016 with around 8 megawatt. And over the course of time, we developed our software that we do not age the battery by charging or discharging it, always doing that at the right state of charge of the battery, right temperature level and so on. So there we learned a lot. And the second thing is we earned money with those batteries. So 2018 it was 1,134 euros per battery. So imagine you as a driver would get some share of it. Would be very appreciating. As I said, we monetize those batteries. And Daimler was so appreciated and say, wow, if you don't harm the battery, we stopped the production of the Smart, and we still need to provide spare parts for another 10 years. Can you, and we have to maintain these spare parts anyhow, so once a year somebody has to charge them, as we know from our motorcycle batteries at home. So why don't you take these batteries, earn money while they are waiting for their spare part usage? So we incorporated another close to 2,000 batteries as spare parts. So in every other week, somebody from Daimler is coming there and taking out 2 or 3 modules because there is an accident or one battery is old of an existing smart and they have to exchange it.
Okay, wow. And how big are the locations now that you're operating, the storage locations? How many megawatts can you?
Altogether, we market every week around 25, 27 megawatt. This we do only to optimize our software stack to learn how to apply batteries to the energy market. So it's not that we want to be the biggest storage provider of this world. It's more that we prepare ourselves already for the future when vehicles are bidirectional. And we also learned with the first storage, for example, we just did one product with those batteries. Right. It's the most complicated and the most advanced product for the German energy system because it keeps the frequency, the stability of the grid stable. So it has to react in seconds. And you have to assure a very secure reaction in terms of security of the system. So all this we incorporated already, but then we learned, just one product will not kind of give us the full ability of earning money with batteries. So we found by coincidence the Amsterdam Arena as a partner. You might have heard about that project because the Amsterdam Arena had the issue they wanted to be a renewable arena. And had to increase their backup power. And they don't want to install diesel engines, which they have today. So they ask us, can't you help us with batteries? And we incorporate their batteries to do backup power when there is a soccer game. And the grid stabilization when there is no soccer game, which is 95 or 90% of the time, or event. Then we learned, the arena has an issue with a peak because they have 1 megawatt base load. They have 3 megawatt when there's a soccer game, and when Tina Turner, Metallica, or Beyonce is coming, they have 6 megawatt. So that peak we now can shave with the battery and save them a lot of money.
Regarding the battery storage locations, how many % of the batteries are first use batteries and how many % of the batteries are second use, are coming from cars?
I think we are around 50-50, perhaps 40-60, second use and first use. This depends on whatever has been available and with which car manufacturer we work together. So for example, we have in Berlin at the RF campus, we have Audi batteries. These have been test-driven batteries, so they did not drive a lot. The smart batteries did drive a little bit more. The Nissan Leaf batteries we have in the Amsterdam Arena, half of it really, they drove 150,000 kilometers already. So it's totally different there. But at the end, the interesting thing is, and most of the people totally forget, this is not only the life of the battery in the vehicle, but there will be a second life possibility. And this is not already kind of incorporated today because the batteries today, they are still kind of have a crazy shape and they are not so easy to be incorporated. But imagine in the future, and if you look to the Tesla batteries, or also now from Volkswagen, the MEB batteries, they have a very clear shape factor, very easy to take and plug and play. You put them into a container, ship them somewhere, and use them for another 1, 2, 3, 5, 10 years, depending on what you do with those batteries.
A thought experiment. Suppose in 10 or 20 years or 30 years from now, Germany would be, or let's say in a few decades from now, Germany would have 100% renewable energy. How much battery capacity would we need in order to balance the grid? I mean, no matter where the battery is located, if it's a battery storage or if we use cars to balance the grid.
I can't give you the right figures out of my mind now, and also we have to be kind realistic battery, also in a vehicle, can solve everything. So you would also need stationary storage to a certain extent, and you especially also need long-term storage, which is not a lithium-ion battery. Right. But we can save or solve a lot. To give you a value I know, we want to have 10 million vehicles by 2030 in Germany. By that, Germany would have 65% of renewable energy. Currently we are 46%. I hope that we get all these renewable energy issues we currently have with PV and wind solved, so that we have a growing and prosperous industry there again, achieve the 65%. And then with these 10 million vehicles, we will have around 500 gigawatt hour on battery capacity in the German market. Currently we have 40. So we have 10 times the capacity, or more than 10 times the capacity of storage in the German market. So we can solve a lot of issues. And that would be an investment done by corporates, private people of 50 billion euros. So this investment is there. So what is necessary now is to create the regulatory framework to use this investment, to utilize it towards a more renewable energy system. Because otherwise we need to build even more wind or more solar, because we can store the energy. And the storage in a vehicle is already there. And the storage in a vehicle normally is there for 400 kilometers, but you just drive 40 kilometers a day. So you can utilize a lot for storing energy. And everybody who has a PV system on his house already, they know very well, though, because normally you use for a household 10 kilowatt hours a day, 4 during daytime, 6 during nighttime. So ideally you, which more than 100,000 people do, store sun in a home storage and use that over the night. So you need a 6 kilowatt hour home storage to use everything overnight, which is an average figure, but just to give you an impression. Right. And we sold more than 100,000 of these 6 kilowatt hour home storages already. Why shouldn't that be a vehicle which has normally a 60 kilowatt hour battery incorporated?
We're talking about vehicle to grid and vehicle to home. Can you very simply explain the idea of vehicle to grid or vehicle to home?
So first, vehicle to grid means it's somehow controlled smart by serving the energy and a grid world. So this can be first unidirectional, as explained before, so that we do not create any peaks, that we charge at the right time, so when energy is cheap, but it can also be bidirectional. And the Nissan Leaf is capable since a couple of years already to do that. So we could then also discharge the vehicle at night. This would be then vehicle to home if you do it within your premises, behind your meter. Or you could also sell thousands of Nissan Leafs, stored energy towards a market player, and then it would be vehicle to grid. So because you deliver the energy beyond your metering point.
So regarding the incentives, for example, for vehicle to home, what is the incentive for somebody to use their car to power their house at certain times of the day? Is it economical, or is it people who want to just be very independent with their power source?
So the current incentive is more on a, how would you say, it's an attitude. So you just want to be self-independent to the maximum extent. So you want to increase your self-consumption as much as possible. Is there already a business case? kind of behind buying, for example, a stationary storage, rather not. But this will change over time, because especially if you not only use the energy for yourself, but also give it perhaps to your neighbor, which is using it at a time where the energy is more expensive, or giving it to an aggregator, somebody who can use it in a more global manner. They are willing to pay much more for your energy. So then it's leaving that vehicle to home part, which is more a habit or a philosophy. Then it's really kind of creating value. And then it's also the question if you own the battery of your vehicle, or if you own your vehicle anymore. So, or if you not just have a leasing rate and your kilometer is cheaper, or you don't pay for your energy bill. We always say zero emission, zero cost for driving. I bet with you a good bottle of red wine that by 2025 there will be a country where you do not pay the energy for driving your electric vehicle if you charge at the right time and also discharge at the right time.
So that's one question I wanted to ask about vehicle to grid. What are the feed-in tariffs? Is it the same when you have your solar panels on the roof and you feed electricity into the grid, or what would be the incentive for a car driver to provide his electricity to the grid?
So currently this is not possible for one single car driver.
Okay.
But at the end we think about aggregating, let's say aggregating all the Nissan vehicles, or aggregating all the Allianz vehicles, or aggregating all the vehicles of a certain community, a city. Then you offer a huge controllable load or capacity to the energy market you can release immediately. And what I started in the very beginning with more and more renewable energy, you have very, very high volatility in the market. So you need immediate reaction. There is nothing in the energy system currently which has such an immediate reaction than an electric vehicle. So by bundling that, offering that to the market, you will earn the money.
It's a very futuristic concept. Is there more manufacturers, car manufacturers, that plan to integrate the bi-directional charging?
Nissan, or the Japanese car manufacturers, did that because they had Fukushima. And Fukushima, they realized, wow, we had the first electric vehicles. At that time, this would be a backup power, so emergency power supply, a vehicle, because at that time the battery had 20, 30 kilowatt hours. It's about 2 to 3 days backup power for whatever you need. And then the Japanese regulatory body said, we need to have a standard that you can also discharge the battery. Because from a technology point of view, each vehicle can do it, because you charge it, and by driving you discharge it. So what is the missing link is not a technical component within the vehicle, it's kind of the standardization. How do you tell the vehicle now to discharge via the plug? Everything is there already, but you just need the communication protocol. The Japanese created that communication protocol within 3 months due to that emergency issue they had. The Germans, or the international community, is now working on a bigger standard, the so-called IEC standard. And that standard is close to be finalized by this year. And then also all the other vehicles, the non-Japanese vehicles, so those vehicles you're using Type 2 or CCS standard, are capable for bidirectionality.
Okay.
Certainly some software adaptations and things of the car manufacturers are needed by then, but I assume that latest in 3 years, every car manufacturer will be able to offer bidirectionality. The technology is there. We qualified a Nissan Leaf as a power plant in the German system. So we did all the paperwork, we did all kind of the technology, the software and security standards needed to offer that vehicle as a power plant. So the folder is air thick. There is a folder placed right beside it for a power plant with 4.4 gigawatt, which is the second largest power plant in Europe, or the largest one in Germany. It's a lignite coal power plant, and right next to it, it's the Nissan Leaf with 7 kilowatt, fulfilling the same requirement than that power plant. So technology, it works. So it's not futuristic. What we now need to scale it, so to make it cheaper, because a charging station is too expensive, and every vehicle needs to have it, and. But the most important thing is we need the regulatory framework to allow that.
Which policy would you really like to see happening, which could really help to bring all this technology onto the streets regarding vehicle to grid?
We had three principles which is needed. First, we need to have a proper taxation. So, for example, currently stationary storage do not pay taxes for kind of storing energy, so charging and discharging. Mobile storage do, which is somehow kind of inconsistent. So we need to have fair taxation. If you provide services for the system, you can't be taxed on that. But if you provide a service to the system, if you reduce CO2 in the system, if you stabilize the grid, if you avoid grid extensions, kind of opening roads, digging cables, you should consider that as a service and not double taxated. Second thing is that people participate, they need to be incentivized somehow. So we need to have an incentivation that people say, okay, I do not charge at 5 if I come home, but I defer it until 9, because otherwise everybody say, plug it in and charge. I don't care. But if you get, like in California, half the energy price after 11 o'clock at night, they just set a timer, start charging at 11:15. Right. So this incentivation we need means dynamic tariffs on the grid side, but also on the energy side. Okay. And third is we need to digitalize our world. So what you see currently, that smart meter gateway, smart meters itself, you have Eichrechtskonformität in Germany, so that the metering has to be kind of certified. This is all done in the old energy world, so it does not consider kind of the new digital world where I also use the phone the whole time, right, and I'm built, and this is working properly. I don't need a meter in that size, and for 400 euros a year. Right. So we need to digitalize and optimize all the components of the system. These are the three major things we see.
So what is the added value of vehicle to grid in the climate change perspective?
The major added value is that you can incorporate more renewable energy, because you can store that energy. And we did a presentation to the German government where we explained them, look, if you have an electric vehicle, you have already emission savings tailpipe of 2.2 kilotons per year by driving electric and charging that with green power. But you would even increase that, close to double it, with another 1.7, because we could assure that we only charge the vehicle when there is green energy in the system. So not the average mix, some green energy, 46% in Germany last year, and some kind of black energy, which is then gray, in the phrases you use in that energy world. But we can only charge when there is green energy in the system, and even discharge when you would start kind of pickup plants, or you only have the possibility to drive lignite coal power plants. And that is a huge value add, which comes nearly for no cost, because it's there already. The storage is paid, the grid connection is there already, everything is there. You just need a regulatory framework that people do it.
So is it correct to say you're trying to do a proof of concept with the island Porto Santo close to Madeira, where you try to put all the technology you developed to use? Or what is the idea with Porto
Exactly.
Santo?
This is Europe in a small scale. So that island has no landline, so it's totally independent. They have a huge diesel generator, they have wind, they have solar, and they now incorporate electric vehicles. And what we did together with Renault and the local utility, connect these electric vehicles smart. Also, 2 of them are bidirectional, to learn already how much more could we achieve if all vehicles would be bidirectional. Also, we have a stationary storage to compare vehicles and stationary storage, or to avoid if too many vehicles are driving around and not accessible for any use case. And with that, we want to kind of avoid the use of the diesel generator and just charging the vehicles by wind and solar, discharging it overnight, or if there is no wind or if there is no sun, which is hardly the case on that island. It's a really great place. So kind of showing in several steps that you can achieve a independent or storage-based island, and then scale that to continental Europe.
And is the island already at the moment 100% renewable, or how far are you on the way?
No, they just started with renewables. And as soon as they started, they stopped, because they realized, wow, and you can imagine an island, very small, 10 kilometers of grid, when there is wind, which is always very fluctuating on the sea level, it's not so stable. They have 2 hertz fluctuation in their grid. So they need balancing elements, which can take the load or discharge then to stabilize that grid. So they need electric vehicles or stationary storage, but vehicles would be better because they also want to drive around.
They carry the storage within them.
Exactly. To incorporate more renewables there.
Well, Markus, this was a very interesting conversation. Thank you very much. I think it's some very great products and solutions you're working on. I wish you all the best and hopefully see you soon again.
Great. Thank you for having me.